This periodic table shows the historic discovery of the elements. We have learned that the ground state electron configuration of the elements follows certain patterns. Let's look at groups 1A through 8A, the representative elements. 1A fills the NS1 level, 2A the NS2 level, 3A NS2 NP1, 4A NS2 NP2, 5A is NS2 NP3, 6A is NS2 NP4, and the halogen 7A NS2 NP5. The p orbitals are complete by the noble gases NS2 NP6. N, remember, is the row number. The transition metals, the B groups, fill the d orbitals. There are 10 transition metals for the 10 electrons that can fill the d orbitals. 4F is the lanthanides. There are 14 of them, as there are 7 f orbitals. 5F are the actinides. This shows you the classification of the elements. The gray are the representative, noble gases in green, and the transition metals in blue. Lanthanides and actinides, pink and a darker green. Let's look at the electron configurations of some cations and anions. Sodium is neon 3s1. The ion is formed by removing the outermost electron from the 3s orbital. Similarly, calcium is argon 4s2. Remove those 2 electrons and you have the calcium ion. Aluminum 3s2 3p1. Aluminum 3 plus removes the 3s2 electrons and the 3p1 electrons. Atoms lose electrons so that the cation has a noble gas outer electron configuration. Let's look at some anions. Hydrogen 1s1. The hydride is 1s2, that is, it takes on another electron and becomes the same as helium. Fluorine is 1s2, 2s2, 2p5, taking on the electron and becoming like neon. Oxygen 1s2, 2s2, 2p4, and the oxide is 1s2, 2s2, 2p6, again similar to neon. Nitrogen 1s2, 2p2, 2p3, and the nitride is again like neon. Atoms gain electrons so that the anion has a noble gas outer electron configuration. We learned that the groups of the representative elements can be categorized by the charges that they take on. So 1A is +1, 2A is +2, 3A is +3, 5A is -3, 6A is -2, and 7A is -1. Isoelectronic means that the same number of electrons as the ground state electron configuration of another element. So sodium ion is isoelectronic with neon. Aluminum ion is isoelectronic with neon as well. And the fluoride ion is also isoelectronic with neon. Oxide, similar. And nitride, the same. They are all isoelectronic with neon. The transition metals are a special case. When a cation is formed from an atom of a transition metal, electrons are always removed first from the ns orbital and then from the n-1 d orbitals. Let's look at some examples. Iron is argon 4s2 3d6. To make the iron 2 plus, we remove the electrons first from the 4s orbital, so that its electron configuration is then argon 3d6. Iron 3 plus, we take again the 2 electrons from the 4s orbital and one of the 3d electrons, making it argon 3d5. Manganese, argon 4s2 3d5. The ion Mn2 plus is argon 3d5. Again, removing the 4s electrons first.